All right, this is test review A solutions. We're on page 150, and we're going to work these problems right here. So number one, we have to take the derivative using the definition of the derivative. So that's the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. And the one we're going to work is f of x is equal to x squared minus 2x plus 3. So f of x plus delta x, everywhere there's an x, right here at x squared, right here at x, we have to substitute for the x plus delta x. So I've already written that out here. X plus delta x all squared. 2 times x plus delta x plus 3. And then minus f of x. Well, f of x is just this function right here. So minus, I'm putting it in parentheses so that I remember to distribute that negative sign. So we're going to FOIL x plus delta x out. All right, write it twice and FOIL it if you need to, but that's x squared plus 2x delta x plus delta x all squared. And then distribute this 2, so minus 2x minus 2 delta x plus 3. And distributing the negative sign here, I got negative x squared plus 2x minus 3. Now, a lot of terms are going to cancel out. We've got x squared. We've got negative x squared. We've got 3. We've got negative 3. I've got negative 2x, positive 2x. So all that's left are the delta x terms. So we have the limit as delta x approaches 0, 2x delta x plus delta x all squared minus 2 delta x. Right? That's all of them that haven't been canceled over delta x. We can factor a delta x out of the top. So if we do that, I've got delta x 2x plus, if I factor out a delta x here, I'd have delta x, and then factor a delta x out of this term, and we'd be minus 2 over delta x. We can cross those delta x out, cancel them as long as delta x does not equal 0. And we're taking the limit as delta x approaches 0 now of 2x plus delta x minus 2. Going to plug that 0 in right there. And the answer is 2x minus 2. And now that you've learned all the shortcuts, you know that that's the right answer. But on the test, you have to show me every bit of this work to get credit if I tell you that you have to take the derivative using the definition. Okay. So pause the video if you need to, and let's move on. And on the test, there will just be one of those that uses the formal definition. All right, number 5. On number 5, we're going to state, and also number 6, where is it not differentiable? Well, it's not differentiable at a sharp turn, number 5. So that's going to be at x equals negative 1. And it's also on number 6, not differentiable at a vertical asymptote. So that is x is equal to negative 3. So for 5, it's not differentiable at x equals negative 1. And number 6, not differentiable at x equals negative 3. All right, number 9. So for the rest of the assignment, we're just taking derivatives. So we have f of x is equal to 2x cubed minus 1 over x squared. Let's rewrite this. Now you could skip this if you wanted. I'm not going to do the quotient rule if I don't have to, and I've only got one term in the denominator, so we could rewrite this as 2x cubed over x squared minus 1 over x squared. split those terms in the numerator up, and that's going to equal x cubed over x squared. The x squareds cancel. That's just going to be 2x minus x to the minus 2. And now I can use the power rule on that. So much easier to use the power rule than the quotient rule. All right, so the derivative of 2x would be 2. Negative 2, bring that times negative 1, so plus x to the minus 3. Okay, so simplifying that, that's 2 plus 1 over x cubed. Don't forget to do that last step, all right? And I'm sorry about that. That would be a positive 2. All right, because you bring negative 2 times negative 1 would be positive 2 there. All right, number 11. So g of t is equal to 2 over 3t squared. I'm going to rewrite that as 2/3 times t to the minus 2. So g prime of t, negative 2 times 2/3 would be negative 4/3 t, and subtract 1 to the minus 3. Okay, and that's cleaning it up, and in the last step, that's going to be negative 4 over 3t cubed. All right, so make sure you make that exponent positive so I don't have to count a point off on the test. Okay, number 13. Let's see, well, that was 11. Right, all right, number 13. We've got f of x is equal to the square root of 1 minus x cubed. I'm going to rewrite that as 1 minus x cubed to the 1/2 power. So f prime of x, we're going to use the chain rule. 1/2 times 1 minus x cubed to the minus 1/2 times the derivative of the inner function, what we call the blob. So that would be negative 3x squared. All right, so let's clean this up. I'm going to have a negative 3x squared on the top. And on the bottom, we would have a 2. And then you can write this with a radical or to the 1/2 power times the square root of 1 minus x cubed. All right. I don't see any more simplification there. So number 15, we've got f of x is equal to 3x squared plus 7 times x squared minus 2x plus 3. All right, this is a perfect occasion to use the product rule. So the first times the derivative of the second plus the second times the derivative of the first. So 3x squared plus 7, the first, times the derivative of the second, 2x minus 2, plus the second, x squared minus 2x plus 3, times the derivative of the first. That's just going to be 6x. I don't need you to simplify that anymore. You don't have to FOIL this out and distribute that 6x and combine like terms like the book might do. You can just leave it like this. There's no negative exponents to clean up, so I am perfectly fine with leaving it like that. All right, brilliant. We're moving right along. Okay, number 17. So 17, we have f of x is equal to x squared plus 1 over x. Excuse me. I had to get a drink there. X squared plus 1 over x, all to the fifth. This is a chain rule. It'd be a little easier if we wrote this x squared plus x to the minus 1 all to the fifth, because we have an outer and an inner function. So f prime of x is equal to, bring that 5 out front, 5 times x squared plus x to the minus 1 to the fourth. So many students forget that. When they're doing chain rule, they forget that. And also, so many students forget to then take the derivative of the inner function, all right, what I've called the block. So now you've got to take the derivative of that and multiply it. So that's going to be times 2x minus x, negative 1, bring it out front, to the minus 2. Okay, so probably the only thing that we need to do here to clean this up is to take these negative exponents and make them positive. So that's going to be 5 times x squared plus 1 over x to the fourth times 2x minus 1 over x squared. All right, and that is good enough for me. All right, 19, f of x is equal to x squared plus x minus 1 over x squared minus 1. Okay, so this is a quotient rule. There's not really any other easy way to do it. So we've got the bottom, x squared minus 1 times the derivative of the top, 2x plus 1, minus the top, x squared plus x minus 1, times the derivative of the bottom, 2x, all over the bottom, x squared minus 1, squared. Usually on a test I would then have you evaluate this at a particular point. So plug in 1 or 0 or 2 and get an answer there. But that's not asked here, and you don't have to simplify that any further. I'm completely fine with that. All right, 21. We've got f of x is equal to 1 over 4 minus 3x squared. So there's a couple different ways you could do this. You could do the quotient rule, but I always try to avoid the quotient rule if I can see an easier way to do this. How could I rewrite this and then so it's easier to take the derivative? How about we rewrite it 4 minus 3x squared to the minus 1 power. That's exactly the same thing. Now I've got a chain rule that I can do. Negative 1 out front, so that'd be negative 4 minus 3x squared to the minus 2. And then we have to multiply by the derivative of the inner function. So that would be minus 6x. All right, 2 times negative 3, so minus 6x. All right, so cleaning that up, I'm going to have a minus 6x on top. The negatives are going to cancel, but I'll go ahead and write it over negative 4 minus 3x squared, all squared on the bottom. The negatives cancel, and you end up with 6x over 4 minus 3x squared all squared. All right, I do think that's easier than the quotient rule. You should, once you simplify it down, you should get, if you chose to go the quotient rule, though, it'd be the bottom times the derivative of the top, which is 0, minus the top, which is 1, times the derivative of the bottom, negative 6x, all over 4 minus 3x squared, all squared. So you would get the same answer. And it wouldn't be a ton easier, but a lot of times doing this technique and then doing the chain rule really is easier. In this case, it was probably about the same amount of work. Okay, we've only got 3 more to go. 23. So 23, we're getting into the trig, so we're going to be probably using chain rule. 3 cosine 3x plus 1. All right, y prime is equal to, so this is what we call a 2-layer onion. So I would say the outermost, see, I'll do this in purple, would be cosine 3x plus 1. And then you have an inner, which I will do in red, which is just the 3x plus 1. So there's not a third layer on this one. If the angle were squared, or if the whole thing, if we had like a 2 there squared, then we'd have a third layer. Okay, the derivative of cosine is minus sine, so that's going to be minus 3 sine. I went ahead and brought the negative out front. 3x plus 1. And then multiply that by the derivative of the blob, what's in red, the angle. So times 3. So that's minus 9 sine 3x plus 1. All right, that's not bad. 25, y equals 1/2 cosecant 2x. I'm going to put that 2x in parentheses. Okay, so this is 2 layers. The outer function is cosine 2x. And then it's not just x. There's a 2 there, so that makes it 2 layers. So the derivative of cosecant is minus cosecant cotangent. So it's going to be minus 1/2 cosecant 2x cotangent 2x times the derivative of 2x, which is 2. So the 2 and the 1/2 will cancel, and you have minus cosecant 2x cotangent 2x. Okay, not too bad at all. So it looks like in this assignment we don't have any 3-layer onions, but you do need to study those because I would expect you would get one on the test. All right, we have x over 2 minus sine 2x over 4. Well, I'm going to rewrite this a little bit. X over 2 is 1/2 x. And then it'd be minus 1/4 sine 2x. Okay, so y prime is going to be 1/2. The derivative of 1/2 x is 1/2. Derivative of sine is cosine, so minus 1/4 cosine 2x times the derivative of the inner function times 2. So that's going to be 1/2, 2 times the 4th, 1/2 cosine 2x. Now the back of the book would factor out a half, and they'd be 1/2. You know, this is perfectly fine. The book's going to do this. 1 minus cosine 2x You absolutely don't have to do that. All right, and but this is perfectly fine. All right, that does it for these solutions, and I will talk to you on test review B, and then do a conceptual test review at the end of that video.